Welcome back to Lesson 3, Quadratic Applications. So the first part is a review of graphical characteristics of quadratic functions. So the first equation we're going to look at is 2x squared minus 4x plus 2. If you put that equation into your TI-84, you can go to y equals, insert the equation, and then what happens is you should be able to go to your table and get a list of values. Okay, so go to y equals, put in 2x squared minus 4x plus 2, and your first value in this will be, so 18. Sorry about that. We have 18. Let's see, 8. Let's make that smaller there. 8, 2, 0, going backwards, 2, and 8. So then, after you get your table of values, you make the points. So we go right 2, or left 2, so left 2, and up 18. And since that's impossible to graph that point, we'll skip over it. And following the same method, left 1, up 8, and make a point. So right here, here's that point. Do it right there. Sorry about all the black marks. And then we have 0, 2. So here's another point. Here's my y-intercept here. And we have 1, 0. Then we start back over with 2, 2. Then we have 3, 8. So right here is my last point. And then we just make our curve. And then we can look at the characteristics of this curve. Okay? So things we should know by now. The domain of all parabolas is negative infinity to positive infinity. These are facts, right? But the range, on the other hand, the range starts right at 0, So it starts right here. That's my minimum. That's my range. And then it goes all the way up, and it goes to infinity. So when I do this, it goes through 0, so it gets a hard bracket, and then the infinity always gets parentheses. Now increasing, well, that's the point of inflection. It's right here. Increasing, it's starting at, sorry, that's a 1. That should be a 1. I apologize, you guys. That should be a 1 where that 0's at. I made a mistake and was thinking about the y coordinate. So that should be a 1. So increasing starts at 1, and it's pointed up, and it goes all the way to infinity. Okay? Now decreasing comes from negative infinity, and it goes all the way over to 1, and then it stops, the y values stop decreasing. Now, endpoints, it's the end behavior here. It's going towards positive infinity on both sides. So I'm going to put positive infinity. Okay? And the vertex is 1, 0. And the axis of symmetry is x equals 1. The vertex is a minimum, and the x-intercepts, there's only one. It's at 1, 0, and this is a double root. And the y-intercepts are at, there's only one, and it's at 0, 2, and parentheses, close parentheses. Now, we are looking at the real life applications of quadratics. So we're basically, this is like a little introduction. So we're gonna label essential parts. So I'm going to be doing a lot of typing. I hope that you do a lot of writing. And the first parts we're gonna label are our y-intercepts. Our y-intercepts. And we're gonna go back and go through each one of these. So the y-intercepts, so that means we're gonna have y-intercepts in several places here. Okay, so I'm just labeling and getting this ready for you. So here, y-intercepts, all of my y-intercepts, I'm going to highlight. I want you to circle them and label them. But all of my y-intercepts, those are the points where curves cross the y-axis, or where they touch the y-axis. So some of these curves, it appears like it doesn't have a y-intercept, but it actually does. It's somewhere down here, but we don't have that graphed. And sometimes you won't. But our y-intercepts is where x equals 0. Whatever is on the x-axis is 0. So we're going to just go back. I'm going to go back through and type that information in. X equals 0. Okay? Right here, x equals 0. It's an important place. Over here, although it's not that critical for that profit cost uh, graphic, we are going to do it for the last and fourth one. Okay, so on your own map of these graphics, please go ahead and label these important parts of this graphs. So what we're doing now is just labeling, so we're able to find these things and identify these things as we move through this topic. So here are my x-intercepts. Now we're going to go through and highlight the, sorry, that was the y-intercepts. Now we're going to go through and highlight the the x-intercepts. I said a mistake again. So I'm highlighting those blue, and if you notice there's overlap on that last one of the x-intercept and the y-intercept. Now, the x-intercepts, they usually kind of give us a general idea about something. So I'm going to get into that, but first label these things. And so the x-intercepts are very key. They're a very key part of the information we're trying to get sometimes. And like, for instance, let's look at the first graph. The first graph, it looks like starts off above where y equals 0. So starts off in the air, and then it goes down to ground 0. So you could imagine this is an example of throwing a ball or throwing an object, or an object that's traveling over the ground from a certain height, right? Well, that object has a maximum. It has a maximum. Here, y is greatest. Y is greatest. The y values are the greatest at this point. Over here, the maximum, it has a maximum as well. And the y is the greatest. This is the greatest height you'll be. Down here, you have more maximums. So a max and y is at its greatest height or greatest profit there. And I'm just going to make that a little bit smaller. And then over here, our sales, our highest sales are like right in the middle somewhere. So here, y is at its greatest. So you can imagine with a minimum, y would be at its lowest. Okay, now let's talk about when X is at its greatest. X is usually at its greatest at the x-intercepts. It's at its greatest at the x-intercepts. We don't talk about the least usually. We don't talk in terms of that. But here at the end, x, this is the maximum x. So x is the greatest here. So this would be like the max time. For instance, the maximum time. For y, it would be like the maximum height. So over here, in this graph focused on height and age, if you notice, what I didn't do was go back and actually highlight these maximums. So I'm going to do that real quick. I'm going to put, make it pink. So here's the maximum, here's a maximum, here's a maximum, and here's a maximum, okay? So a little bit about this height versus age graph, all right? So if you notice, it's a very steep curve, and then over time, it kind of tapers off. So this curve, it models your height versus your age over time. And what happens from when you're a baby until you're 18, it's a very short span of life for a human being. You grow very rapidly. Your height gets very, very rapid. And when you're about 18, that's when you're at your maximum. Now, as you move farther to the right, the behavior shows you that the graph is decreasing, that the height's decreasing over time, but it's slower than before. And this is because as we get older, we typically shrink in very small increments. And then there is no x-intercept because, unfortunately, human beings die. You die. And at that point, the graph cuts off. It cuts off at the age that the average human being dies. Now, so we don't have an x-intercept in graph number 2. But graph 3, where you have profits versus cost, you have 2 x-intercepts, 2 critical points. And the way we're going to get these x-intercepts is that we're going to set y equal to 0. So here, y, I'm trying to find a nice pin there, sorry. So here, y equals 0. And what we do is we usually use the quadratic formula to solve for this information, okay? So what we're going to do is we're just going to tackle the next problem. So it says the height in feet of an object above the ground is given by h equals negative 16t squared plus 64t plus 190. So when you go to your graphing calculator and you graph this, it looks a lot like the first graph. So the previous 4 graphs were models for what you're going to graph. So I'm going to draw a graph that looks exactly like this graph here and put it in my put it on the paper. So here's my graph. What I find with my graphing calculator is that I'm just going to rewrite my equation because it's going to tell me some pretty nice things. So I have y equals, and in fact, I might even type it. So I'm going to go back and look at the equation real quick. Y equals negative 16t squared plus 64t plus 190. So y equals negative 16t plus 64t plus 190. And I'm going to go back and put the squared in, right? So here that t is squared. Okay? Now, this number that is by itself, when it's in the standard form, this is your y-intercept. That is my y-intercept. So So I can label my graph. I can label this y-intercept on the graph. So this point up here is 0, comma, 190. Okay? That's my y-intercept. Y-intercept. So we're going to take our time doing this. Okay? Now up here, this is our vertex. And so when you're putting this in your calculator, this is your maximum. We're going to call it a maximum or a vertex. Doesn't really matter, but either works. So for the remainder, I'm going to use Desmos to start to do this, finish this problem up. So I have negative 16, sorry, so negative 16, and I'm going to use x instead of t, x squared plus 64x minus, no, plus 190. And I'm going to change my stuff around here. So I'm going to see if I can change this window, and I'm going to make my x-axis much smaller. So I'm going to go between negative 10, no, negative 50 looks like, negative 20 and 20 in increments of 2. And actually, I can see it a little bit closer. It's between negative 4 and, well, 0 actually, 0. So this is what my curve actually looks like. And what I'm going to do is change my y-axis, and I hope that you would do the same. So we're coming from probably about negative 20, and we're going to go all the way up to, let's go to 250. We'll do 260, right? 260. Until I can see the curve in the way that I want. All right? Now, there's some key information I have here. I can already see my y-intercept, and I was right. It's at 190. And then up here, this is my maximum. It's already done for me. It's 2, 254. And I can do this with Desmos easily. So when I go back, my maximum, I'm going to put that on my graph, 2, 254. Now, my x-intercepts are right here. There's only one. And I'm going to go find it with my Desmos calculator. So I'll go back to Desmos, and this x-intercept is 5.984, comma, 0. 5.984, comma, 0. Okay? Now, I need to label these other things. So this is time. This is over time. So it looks like the maximum time that this ball was in the air was 5.984. It looks like the height of the ball, the highest point of the ball, is at 254 feet probably. So I'm just labeling my axes, which I hope that you do as well. And everything I have on here, and my y-intercept, my maximum, my x-intercept. So make sure you do the same thing. And then we're going to go back and do number 2. We're going to do number 2. Okay? Same way, using the Desmos calculator. So I hope that you use this calculator at home. It's a little bit different than using the TI-84. You will have access to both on the SOL. So going back, I'm going to go answer my questions really quickly down here. And so it says, find the time it takes for the object to strike the ground. So we're going to go back and do a visual here. The object is at rest at my x-intercept. This is the time it takes for the object to hit the ground. So here, my answer is going to be 5.984, and that's in seconds. 5.984 seconds. The maximum height is 254 feet. That is the y value in the maximum. Okay? So this actually doesn't take much time. So the next one, a shot put throw can be modeled using the equation y equals negative 0.0241 x squared plus x plus 5.5. Now I know that this is one of those models that look very much like the previous one. So I'm going to go ahead and draw it, and here we go. So it goes up and then it goes down. Now, key information I need, that y-intercept, which I know, in standard form, the only number that matters is 5.5. So that's 0, comma, 5.5. This is my y-intercept. Okay? Now, my x-intercept I'm going to get from Desmos. My maximum I'm going to get from Desmos. But other things I can label right now, I can label the axes. So this is my height. This is the height. Okay? A little bit messy, but it works. This is the height. And then here is, we got distance. This is the distance. So I'm just going to go back and try to, well, it's not going to work, but, and then my maximum is over here. This is my max. Here is my max distance. Okay. So this is my max distance, and right here, this was my max height. So the y value in the coordinates of the maximum is my max height. This is my y-intercept. And for the max distance, I'm looking at the x-intercept. Okay? So just so we're clear what we're looking at here. Now, going to Desmos, I'm just going to put the formula or the equation into Desmos. So I'm going to minimize this so I can see it a little bit better. Okay, and the equation, that is. And I have negative 0.0241 x squared plus x plus 5.5. Now I'm going to have to manipulate this graph a little bit. Okay? So when I manipulate the graph, I go to the screen tool, and I'm going to go with an x-axis from -2 until, let's see if we can't go to 100 and see if I can't see the end. And that gives me the end. So I'm going to do, for my y-axis, I want this curve to be a little bit smaller. So I'm going to go right here to about 20. And there's my curve. There's a better looking curve right there. So important parts here. Right here, that's my y-intercept, like I said. Up here, that's my maximum height, or my maximum, 20.747 and 15.78873. So right here, I'm going to type that in. So 20.747, and let's do parentheses, 20.747 and 15.873. Now I'm going to make that smaller. Okay, and then for my x-intercept, let's go back to the Desmos here, and we have 46.411, comma 0. 46.411, comma 0. So 46.411, comma 0. So I have a lot of key information here just from a few seconds of work. So first it asked me how long was was the throw? What was the distance of the throw? That's what they're asking. So the distance of the throw, the maximum distance is x equals 46.411 when y equals 0. Now the height of the shot, the maximum height of the shot is the y value. So y equals 15.873. And it's in feet. Both of these are in units of feet. So I want you to take the next one and use this equation and answer the questions regarding this equation. So you just go to Desmos, put the equations in, and you go and answer specific questions regarding this information. Okay, so it asks you initially what was the student enrollment in 1970, or what's the y-intercept is A. For B, in what year was the enrollment up to 500 students? It's going to take a little bit of work for that. And then for C, what is the expected enrollment for the year 2015? So I'm going to go work through this with you for a little bit. So T equals 0 corresponds to 1970. So that means for here, so for T 2015 minus 1970, that means T corresponds to 45. So that means we want to know what the enrollment is at where T equals 45. And then in what year was the enrollment up to 500 students? You want to see what the enrollment is, or what the year is, and use that number and add it to 1970. Okay? So we're going to go through it together, if you haven't done it already. And we're just going to go put our equation in. So I'm minimizing and pulling this over so we can see the screen clearly. I'm going to X this equation and put in my next equation, 37. Let me see if I can use T. T up arrow squared minus 14.8T. So I'm going to say, what's my other variable? Enrollment. E equals. Let's see if that works. It doesn't look like it works. So we're just going to use X and Y. So X for T. So 0.37X squared minus 14.8X plus 460, right? So let's see if we can see this first of all. Let's go back to our screen here. Let's play around with this for a little bit. So I know it's going all the way up to 460, so I'm going to go past 460 to 500 for my y-axis. So I'm going to go up to 500 on my y-axis. And look at that. So this has a minimum, and it does not have an x-intercept. Now, I'm going to leave it like that and just go ahead and get some information. So my y-intercept is 0, 460. So I'm going to go back to my graph and make the curve. So this is what it looks like. That's an ugly curve. I'm gonna redraw that. Try to redraw that. That's what it looks like. So there's my curve. Now, important points on this curve, the y-intercept, which is at 0, 460, and I'm gonna go ahead and label the axes. So this is time. This is over time. T, right? And I'm gonna put that it's in years. It's in years. Okay? Now on the right, we have um, the enrollment over time. So I'm going to see if I can make that, if I can shrink that a little bit, and won't let me do it. Won't let me do what I want to do. But anyways, I'm going to just move this down, and along the y-axis I have enrollment. Okay? So my enrollment at year one, I start off with 460 students at year one. Okay? So year one, or excuse me, year zero is 1970. So when t equals 0, then I start off with 460 students enrolled. Right? So it says, in what year was enrollment up to 500? So it looks like I might have one answer here. So we're gonna go back to the graph and find where y equals 500. So here's 500. So we're not going to use any negative values. But over here, what is this value? What is that value? Where y equals 500. So I'm going to go up, and it looks like if I keep moving along the curve, y equals 500 gives me 42.6. 42.6. If you didn't see that, I'm just moving along the curve, moving that little blue button until I see 500. And I want to try to get as close as possible. And another way we could do that, we could add y equals 500. We want to know what x is when y equals 500. So I'm just going to say 500. Sorry. So 500. And it should draw the curve. And then I'm going to make my graph a little bit bigger so I can capture the essence of that intersection. So 520. And my second graph, y equals 500, is right about here. Let's try it again. 500. And okay, so I can't quite get to the 500 that I want. So I'm just looking at where it becomes 500. I'm looking for y becoming 500. And I did say that it's about 42 point, it's between 42.5 and 42.6. So what I'm going to do is look at the table and give me an answer. So I want to know what gives me 500. So 42.5 gives me 499. 42.6 gives me 500. And 42.55 gives me a number that's closer. So let's try 54. Nope, 545. 541. 542. 5412. Or 13. 12. Probably about 42.5 years. About 42.5 years. So 42.5 years plus 1970 is going to give me the year that the enrollment is at 500. So over here, enrollment is at 500, so 42.5 plus 1970. And using my calculator, 42.5 equals 2012. So about 2012, during the year 2012, enrollment's at 500 students. Now, what is the expected enrollment for the year 2015? So I just go back to Desmos and type in 45 on the left. So I'm going to type in 45 and it gives me 543 students or 544 students. So enrollment in that year is 544 students. So basically what you need to be able to do is to either use your TI-84 or use the Desmos calculator in order to answer questions about real world quadratics. Okay, guys. That's the end of this. Please do the math space assignment. Please use this tool, Desmos, to help you with your math space assignments. Have a great day.